I'm here today to present a little bit about some of the research that I've been doing, why I've been doing some of that research, showcase a little bit of my app, and basically tell you guys why I'm using S3 files and S3 vectors within the app that I'm building. And hopefully you guys learned something, and hopefully you guys like my presentation. So the reality of AI adoption and how consumers are using AI. Most consumers don't really use AI the way which we use AI. They traditionally just use ChatGPT. They'll use Gemini. A lot of people using Claude for coding, just to create apps arbitrarily. They're not really actually trying to build like real software. They're just using it to build their projects. And Meta AI. I don't know anyone that uses Meta AI personally, but I just figured that fit the square on there. One of the issues is compliance. In a professional manner, you cannot use these models if you're working with sensitive workloads. If you're working with healthcare data, social security numbers, anything across different types of industries. And the reality is that a lot of people do it anyways. The way in which they use AI, the way in which they use these consumer chat models is they rely on memory, vector database behind the scenes. It could be a financial advisor, lawyers, insurance adjusters, anyone. They upload all their documents and they retain conversations with the models. And hallucinations aside, compliance aside, you deal with the issue of hallucinations. So you have two different issues. You have one that's non-compliant, and two, throughout your conversations, as the context of what you work with changes, you may not get the model may not necessarily be grounded with what the objectives you're trying to achieve. So, taking a look at how local agents reason, they use MCP skills or tools, but the important aspect is they have a state of persistent grounding, where, say you have these a lot of these models actually will create an agents file for you. I'm sure, as everyone knows, who uses Claude or who uses Codex. But these agents also they can create agent files themselves and reference them separately for grounding. And within these models, they have these reasoning passes where they emit tool calls, and they will act. When you're using Claude Code, sometimes they may ask you a question. It asks you for follow-up before you get your final result. That's through actually using interrupts. That's not a final response. That's just another tool call that these models are doing. But what's important about this slide is the persistent grounding and the reasoning loops. So over the last year, I found myself performing the job of an agent. I was dealing with a really annoying civil legal situation. I'm not really going to get into the specifics of it, but I represented myself, and it was really ridiculous how it played out. But the way which I was handling my case was I was manually making all these different markdown files. I was consistently trying to create grounding across all these different types of categories, and I was manually feeding these into different conversations in the ChatGPT. And I found myself battling with, as state changed, as my case evolved, the user memory had context rot, and as I was moving between conversations, I would have to reprompt, retell the conversation, like what was relevant, no, you're wrong. And attrition ultimately wins, but it's really annoying to have to sit there and feed it the same information, to give it the same context over and over and over again. And for me, it was okay, but for professionals, especially with compliance in the consideration, and for making sure that your facts are absolute, and if you're working across multiple cases and you're not hyper-focused on the facts of one case, it's not really acceptable at all. So, I began to ask, how can you build systems that stay grounded? And this is something that everyone's trying to do. And the answer everyone comes to is RAG. That seems to be what everyone's saying, is spin up a vector database, just chunky context, and put it in there. But that leads to, by itself, context rot. If you're just continuously having conversations and you have evolving context, you're going to run into the same issues that I ran into manually. So whether you're using a consumer model or you're trying to create a solution yourself, simply using RAG, it's not enough. But the way to have things stay grounded, it's simple in theory. You just need to have some type of vector database, and you need to have what's called a knowledge graph, where you have records that are always stateful, that are always truthful, and that change only when you need them to change. So I want to ask just the audience real quick, how many people are familiar with S3 vectors? All right, only a few people, Kevin and the AWS guys, and one red badge like myself. What about S3 files as a new AWS service? All right, this is going to be great. I'm actually glad that I got to cover these. So what are S3 vectors? S3 vectors is a feature of the S3 service. And it works by you bring your own chunks, you yourself embed those chunks. So it doesn't care how you embed them, as long as you embed them to the degree which the vectors need to be in the bucket itself. And you provide metadata. So the metadata can be anything which you want. And on the other side, retrieval, you can use a prompt, use the same type of embedded model, and you're able to retrieve that information, namely the metadata that you encode with your chunks in the S3 vector data bucket, or you can directly use a vector key and just one-for-one get. And the reason why S3 vectors is appealing, significantly cheaper than the alternative solutions if you're going to use other vector databases like Pinecone or OpenSearch, because you're not paying for compute. You're not paying to replicate that data. You don't have to worry about that. Your data is just stored in S3. You don't have to continuously keep the compute ongoing at all times. So if you have a user that's not really using their application much, you're not paying for that extra compute. They can use it as needed, and it's like 10 times cheaper than other solutions. So that's a big draw for me. So back to the diagram that I was showing you before. We're going to move on to what S3 files are. So with traditional S3, if you want to access S3 through a backend server, that server needs to have credentials, AWS credentials, and then the front end client will interact with the back end server, and the server itself, however you implement the code, will make those get and make those put requests. But another model for access in S3 is front end. I don't know if a lot of you know this, but front end clients can directly interact with S3 themselves if they themselves have credentials. Using a service called STS, Security Token Service, you can actually provide temporary credentials to users of your front end. So you don't have to use a middle server at all. You encode and create the exact credentials they need, such as to access a very specific prefix within an S3 bucket. That way they can't access other people's data, and they have a secure route in order to interact only with things that are relevant to them. So it protects the data in your back end, and it gets the server out of the way, and it lets your client directly interface with it. And so that would be the preferred method or model if you have front end that's interacting, such as if you have like profile pictures that are stored in an S3 bucket. Why do you need to go to a server? Just let people get their S3, just let people get or upload their own profile pictures themselves. It makes more sense. Puts more things in the front end and eliminates compute that you need to manage. So S3 files, what S3 files does is it creates these mount points within your VPCs, and it can actually use multiple VPCs. It's built on top of the technology for EFS, Elastic File Service. Elastic File Service uses the same type of mount points, but it's actually limited to a single VPC because the service runs at the VPC level. And the pricing is actually the same for S3 files. S3 files allows you to create these mount points, and you can, in a POSIX style, in a POSIX approved way, you can, within your EC2 instances, within Lambda functions, or within ECS directly, you can mount to these, you can connect to these mount points, and then using native system level calls, such as you would traverse or edit files within Linux yourself, you can interact with S3 directly. So you don't need to use the S3 client. So say you already have a program, you have legacy software that uses native commands and it expects a directory already on your PC. You can use that legacy software still, and the inference speed is significantly faster when going directly through these mount points, as opposed to using the S3 client. And I'll have more on that in a little bit. So a little bit about what I'm doing, and I'll get back into the S3 files aspect, is building knowledge graph for records and relationships. Does everyone know what a knowledge graph is? Raise your hands. All right, most people do. Great. Knowledge graph is just a node-based, graph-based way for agents, or it doesn't necessarily have to be agents, but just agents in this age to be able to traverse and connect and move along your data. Using S3 vector buckets and RDS, you can, with knowledge graphs, you can actually create basically a two-way connection where as your context is encoded for any individual record, you can keep you can document and keep within RDS or any SQL, for instance, where those records are specifically. So say you end up wanting to delete a record, you'll be able to go through RDS, find out where that node is, find out where along the graph, and remove it, and then reference using the vector key the actual chunks within your vector store. And the whole purpose of this is to eliminate or mitigate context rot, a problem that seems to plague everybody. If you go across job forums, you're looking for work in this field, you'll notice something that is repeated time and time again is creating models or creating agents that are able to reason using RAG. And understanding how to avoid context rot and implement solutions it's very important. So basically what I just said, like if you my solution to this is if you create a record in RDS, you create a chunk, using the vector keys, you store those chunks within S3 vectors. And conversely, you delete a record, you do the inverse process, and you're able to delete those. So your data is always fresh. Your RAG database, it's always relevant. It's not going to hallucinate. So as the context of what you have evolves, your vector store will always remain in sync. So a little bit about the way I've decided to implement a knowledge graph is it's not necessarily an easy solution. It sounds easy on its head, but there's a lot of different aspects when you really try to create a comprehensive solution, and if you're trying to make a serious product. And nodes and links can have many different states. They need to contain many different types of states. They need to encode a lot of different types of data. And my solution to a product that I'm building is I decided to kind of categorize what a record can be, so you can segment them. what is, in my case, I'm working on an app for lawyers. So I've been experimenting with and decided to basically categorize things as it can be objective, it can be a claim, it can be a theory, it can be an issue, it can be a question, or it can be a fact, timeline event, so on and so forth. And I've taken direct inspiration from deep learning and neural networks in this design, as in I'm kind of grouping certain types of records together as if they were hidden layers, so to speak. And records can have different types of statuses: proposed, accepted. They can have different types of support statuses. Is it supported? Is it not? Working with links. Links are directional, and that's on purpose. They have an explanation which explains why they are connected the way they are. Links can have different types on top of directions. It's important for these models to be able to understand when traversing, not only which direction are we moving, but why is this relevant? Is this required? Is this explained? Does this contradict in the direction which you're moving? And adding strength to it as well. So these are some renderings I made in Blender to kind of simplify what I'm building. So say you have a layer of accepted records. This is what is reasoned upon by the agent for the knowledge graph. You can have proposals. Proposals are what are only created by the agent. We don't want the agent ruining and messing up our clean data, messing up what we establish as truth. So my solution to making sure that as things are generated, the context is not just arbitrarily just substituted out and removed within my vector store. Anything that an agent suggests or creates, it's going to be proposed. It's going to be something that's abstracted from my graph. And they're able to link directly to the graph. And so if you accept those, they become a part of the reasoning. And you're able to add, part of what I've been creating, it allows you to replace records. So you can create proposals that not only are new, but proposals that are version controlled. They point to things which already exist. And then you can replace things that exist and reference why didn't this work? Why was this rejected? And, look into things that are version controlled, and this is for compliance reasons as well. So I found myself running into these problems of complexity. When you have things that are accepted, you have things that are rejected, you have proposals, and everything's linking together. How do you control propagation? How do you dynamically change the strength of links? What can you change? What are you allowed to change to not ruin the graph which you've built up? And the solution is the model, the agent will only the blue nodes are proposals, just for context, and anything linked to a proposal is a dotted line, so that's a proposed connection. The agent will not traverse any of those. The agent only wants to traverse truth. So that's the green and the red. The red is rejected. So my agent only wants to traverse what is truth, what has been rejected, if it's been rejected, why, if it's truth, why. And as you create proposals, as they become truth, the agent won't just recompute the whole graph, because that would be insane to try to dynamically change how everything and the references to how everything is connected and why everything is connected per change. So the agent itself, it needs to have reasoning and slowly go out and examine the links beyond itself and say, hey, does the change we made, is this relevant? Does this change this? Does it change this connection? Does it change this edge? And if so, does it change this next record? And slowly traverse out. And as you move forward and further away from the initial change, you want to be able to rank that distance and take that into consideration. That way, you are editing things in a smart manner. So the way my app looks now is I wanted to make it as intuitive and I want to make it as intuitive as possible for lawyers specifically to be able to reason about their cases, because people don't the clients you're building for, you're implementing these solutions for, they don't care about a graph map. They don't understand. They just want it to work. But at the same time, when you're asking humans, when you're asking clients, when you're asking people to, they have to have a hand in this process. They need to approve things. They need to be the human in the loop. They need to be able to interact with it. So, a big part of what I've been working on is trying to bridge the complexity to the simplicity which the end users need, because it's one thing to make and implement RAG or implement dynamically update in vector store and making sure they don't have context drop, but to have a human involved, somebody who's not a specialist in this field, it's a very challenging solution. So my app allows you to generate all these different types of records that are very small, and I use the O.J. Simpson case. My wife actually gave me that recommendation. And say we grab some type of record. So there's detective bias. You have information such as within this record, this is partially supported. This is a theory. There's versioning history which you can traverse. There's an explanation why this is partially supported. You can see everything which it's connected to. These things are all direct connections. They're all accepted records. You can go within and you can see how strong is this. You can see the link type. This depends on. This is the direction. You can see this theory connects to this fact, why it connects to this fact. Or you can see how it connects to other proposals, such as this link strength is moderate. This theory is a dependency of this objective. Why so? Claims, evidenced by, so on and so forth. And the users, they don't need to understand. They don't need to understand the back end that there's different types of link types or there's different types of record types. It's just intuitive. That's when you're building out these agentic products, when you're building out these agentic solutions, you really want to continuously ask yourself the question, how can I make this make sense to people who do not understand what agentic is? You don't want them to even hear the word agentic. You just want them to hear AI and give them the ability to reason about your knowledge graphs and just make it as intuitive as possible. And you want to try to basically simplify things as two-dimensional as possible for them. And it's a very hard problem to solve, but that's that's the product I'm working on. But back to I forgot about this slide. This is essentially how it looks when you have your case built up, and it reminds you of a neural network, but it's not. It's a dynamic reasoning graph where you have all these different weights essentially that are changed. You have all these different records, but not everything's connected to each other. Things are connected as needed. Things are connected as the human accepts the connections. They accept the proposals. The AI suggests them, and you change them. You create suggestions over time, and then the AI the proposals that are created. They try to group them into these categories. Hidden layer inspired, where you have things such, and it tries to push them forward towards truth. So you have a claim can be related to an issue, but a claim can also be related to a task or a theory. A claim could be related to legal precedent, but most of the time it's not. So, it allows for connections to exist between, hops, but at the same time, with my model, I've really tried to create a solution that allows for intelligence to just be intuitive for the AI itself and for humans at the same time. And I've done that by creating a dynamic reason graph. So, estimating the workspace sizes and estimated record counts. So I was able to do analysis on the records that I'm generating, and I found them to be approximately in between 1.6 and 1.8 kilobytes each. So I was able to find out and do just basic metrics. I asked multiple different AI models based on different examples that are provided. What type of matter, how many do you think records would you estimate, and how much data is going to be needed per case. And it's really not that much even for a very complex, like large commercial litigation, a complex trial. 1.4 gigabytes, that's not a lot. So I moved towards trying to figure out what would this cost in AWS? What would this cost in implementing an AWS solution? Because the reality is, it shouldn't cost hundreds of dollars to create an app. And AWS does have a generous free tier, and I recommend everyone take advantage of it. You should be able, if you can't build your startup within the free tier, or at least get a lot of what you're trying to build going, you might need to reevaluate what you're doing. So I was able to through doing estimation, I was able to RDS is by far the greatest expense within this, just because of compute. Everything else does not require compute. Whether you have, because I'm implementing all these solutions, S3 standard, S3 vectors, S3 files, relatively inexpensive. You can see if anyone wants to take a picture of the price in here, free to go ahead and do so. And I went ahead and estimated the storage costs based off of that. And if you have a workspace for a client, and they're only holding, that's supposed to say RDS infrastructure, by the way. Sorry, this is last minute. But if they have 1 gigabyte of workspace data, which is more realistic to what a case would be, S3 natively just for the records, they're paying 2 cents per month. For S3 files, they pay about 30 cents. And for S3 vectors, about 6 cents. RDS, this compute can also be shared across different projects, different users. So don't think this is like $25 to $100 per user. That's insane. That's like kind of how much you'd be paying arbitrarily, like across a bunch of users, but you'd scale that up kind of as you need it to go. But that's by far the greatest expense. So this is just another pricing chart based on the estimated storage costs for different type of cases that I just presented. So like if you have like a self-represented housing case, you don't need that much space. You're paying that user, you're only paying 2 cents to 5 cents aside from like the compute for RDS per month. So if you're billing somebody $200, $300, $400 a month in a subscription, the markup is very lucrative, to say the least. And even for a large case, where they're dealing with thousands and thousands of records potentially, which I don't know why you'd be using my platform if you need to do that many. You just want to hire a big firm. But when it comes to a complex criminal trial or malpractice, which my software, my product will be able to assist you with, it's cheap. To be able to build this product and the markup, which and profit you can make, it's unreal when you're using AWS. So I want to really kind of go back to S3 files, and why would I want to use S3 files over the native S3 SDK? Because agents, you can use tools. You can just create a tool for interfacing with the S3 SDK instead of an S3 file. So if you're creating a new native solution, why does it matter? Because in the age of AI, just create a tool. It shouldn't even matter. Why do it in the first place? So to answer that question, does anyone, show of hands of the people who know about AWS Private Link? All right, not that many. So AWS Private Link allows you from within a VPC to directly connect, not over the internet, but directly connect from within your VPC to pretty much any AWS managed service. And so privately, directly, significantly faster than going over the internet. And it's also a compliance thing. A lot of companies, they do not want you going over the internet to interface with S3, interface with whatever. So a private link is essential if you're in a compliance-based field. There's something that's called the gateway endpoint. It's a type of endpoint provided by Private Link, and it's free. It's 100% free. I recommend everyone take a picture of this, learn about gateway endpoints. They're not enabled by default. Enable them if you're interfacing with S3 or Dynamo. They're only for S3 or DynamoDB. And from your private subnets, you can connect directly to S3 or DynamoDB, and it's significantly faster, and you don't have to pay the outgoing data charges that AWS will charge you for your data leaving AWS's platform. So you're actually saving money and getting increased speed by using these gateway endpoints. So I ran some benchmarking. And this is the final slide, by the way. So I ran some benchmarks for the S3 SDK. I was building my agent line graph using TypeScript. So I wanted to do diagnostic tests on Node.js. And because my agent is expected to be going out and grabbing records and then finding out, should I grab more, should I not? It's going to be traversing the knowledge graph. There's going to be concurrency involved. There's going to be multiple requests going on out at the same time. So I can send requests in parallel. You'll notice that as using Node.js, sending out, this is the instance I use, by the way. I use the M7i Flex Large, 2 vCPUs and 8 gigabytes for all these tests. So when I made concurrent requests, 10 at a time, it took 41.32 seconds in order to download a 1 gigabyte data set. Consisted of 10,000 files. And when I increased the threshold to be able to 100 concurrent requests, it started to kind of stall out. And there's a few different reasons for that. One, if you're using Node.js, there's actually caps on the amount of, you can override it, but there's caps on the amount of requests that can actively be going out at the same time. And on top of that, there's also networking aspects to it as well that, depending on, that are implemented in the back end of AWS. So a couple different factors to that, but realistically, practically, I'm not going to be able to be using a concurrency of 100 for my app because I'm not grabbing 100 records at once. I'm grabbing like 10, 15 records at a time. So even though, yes, I can get double the speed by making all these concurrent requests, it doesn't make sense to me because it's impractical. I'm gonna be operating within that threshold. So that is the speed which I'm operating at in order for my agents to perform inference. So I did the same benchmarking through S3 files, and these are the results which I found. So I actually learned a little bit while doing this. I learned that I didn't know that Linux has a cache for system calls. Linux has a cache if you're traversing the file system and reading files, it actually caches those files. I had no idea about that, so it's something I actually had to factor in order to do benchmarking properly. And S3 files, I neglected to mention earlier, it has a built-in caching system. It caches records which you request. Well, not necessarily, not records, but files. So if you request a file, it actually caches it within the mount points. And you can control that cache. You can control the expectancy and the size of what's cached. So when you request in files, if the agent is working through S3 files and it's grabbing and getting files and it's working through them, it's doing whatever agentic process you have, it's going to be caching all those files along the way. So if you have to ask other questions that are going to reference the same files, or if you're not using an agent and you have like some type of application you're building and it's using the same files over and over, it's going to cache those files. And on top of that, your Linux will also be caching those files at the same time. So with both of those aspects in mind, the first test I ran was Node.js, assumed that there was no caching in Linux or within the S3 mount. And in order to download 10,000 files over 1 gigabyte, it took me 33 seconds, which is a little bit better than, it's about a 25% increase in time over the native solution, which I realistically was working with, which was a concurrency of 10 using the S3 SDK. But I noted, very quickly, when Node.js had, I wanted to account for the Linux cache being cleared, and I wanted to account for it actually S3 files and account for that cache. When data was cached, you'll notice there's a significant drop-off, and I was able to download that data within 12 seconds and 12 and a half seconds. So, and then I wanted to compare Python as well, because Python uses C binaries under the hood in order to do input-output, in order to do system calls. It's not like JavaScript where it's using like a translation layer. It's actually using C directly. So you'll see that even once I introduced Python, even when the mount was cold, even the mount points were cold and the Linux cache was cold, saying there's no cache at all, significant increase over just using the HTTP calls over the S3 client. So even without any caching involved, I was almost 10 times, approximately like 10 times the amount of speed increase. That's without the cache. But the end result was if you're interfacing and the mount is warm, the cache is warm, so you're reusing the same, you're inferencing over the same files, the same data. I had approximately a 26 times increase in file download speed into my the service I'm building, which is huge. It's not even that much more expensive. It's pennies cheaper. So S3 files is for the service which I'm trying to build, where I'm trying to have my agent work across file systems. One, I get the native benefit of not having to use those tools to convert gets and puts and deletes and everything into the S3 SDK. Instead, I'm able to natively interface with it using native system level calls, and I get a 26 times factor of reading speed into my system. So for just pennies more per user, it's a clear win. It's an absolute win, and I would highly recommend everyone to look into using S3 files. And that's the end of my presentation. That's my LinkedIn if anyone wants to scan it, anyone wants to connect with me. Might be looking for assistance with the product I'm building. So if anyone wants to even shoot me a resume, I'm always willing to at least see what you have to offer. You'd have to be passionate about the product I'm building, and you'd have to really sell me on it because it's just me as of now. But I'm willing to have a co-founder if they bring the right skills. Or if you have any questions just on AWS in general or any job opportunities, certainly reach out. But that's the end of my presentation. If anyone has any questions, feel free to ask.
Yeah.
Yeah, I'm curious, you have built kind of what Neptune already offers, so I wanted to understand what were the trade-offs you made to build your own knowledge graph instead of using something that kind of is a managed dish service.
I try just because I want it to work exactly as I want it to work. I want to be able to encode data within the nodes exactly as I want, within the edges as I want. I want to be able to control the data structure at every single degree, and I want it to work with S3 files, so I'm not managing compute. Yeah, that's another big aspect. I don't want to manage compute. I want to be able to directly interface with it using S3 files. To me, it's just a lot simpler, significantly less expensive, and it allows me to kind of tune my solution for the knowledge graph exactly to my exact needs, rather than relying on another proprietary solution. I'm able to create something that is, my own, and Neptune might be possible to substitute in some way, some form, but I'm somebody who believes in just trying. I have so many services already baked in. I like to minimize the amount of walled gardens that I'm operating within, and just maximize the control of the products which I try to create.
Thank you. I think a lot of people are thinking exactly what you built about the memory management and
It's a very complex problem. So it sounds easy on paper to just change reg or change the change the underlying embeddings, or curl them, remove them as needed, manage them with RDS, and then as you begin to try to map out those relationships, as you try to create a product, the complexity scales significantly, exponentially, and it becomes an actual, a real software engineering problem to solve. And I've learned a lot. I find it very challenging and very fun to and I think anyone who wants to be involved with in the AI space, these are questions and things that I advise everyone to try to pursue and learn about.
When you gave a brief preview of the application, it looks great. Have you gotten feedback from any legal professionals on how they might use it or how it's constructed?
Not yet. I do have 2 people in mind that I personally know that I plan on. Once my MVP is fully finished, I'm like 80% of the way, but that is literally the next step. Is first I need to work 100% in certainty,
Right.
and then begin getting feedback, refine based on the feedback, adjust, and then hopefully bring it to market if possible. That's the ideal. That's the goal.
Awesome.
Right, so we're going to get kicked out of here momentarily. So if there are more questions, let's ask them as we are cleaning up.
And I'll
And
send
big
a survey
one-
out on meetup.com that I.
Any last question? Yes, sir.
So why did you choose the legal domain as opposed to say something that you're already a subject matter expert in?
That is a very easy question. It's because I went through a legal situation of my own, and I was forced to learn as much about law as possible. And I think everyone in this world, we build products based on the things which we experience. We build things based off of technology we learn. People learn Python, they build something in Python. They learn C, they build something in C, so on and so forth. And it's just based on my experiences and based on a need and a niche which I've seen, and I decided that, hey, maybe all this stuff I learned shouldn't be for nothing. It should be for, and maybe I can create something worthwhile out of it.
All right, big round of applause for Matt. So let's make our way to the elevators.